Okay, so welcome, Damien. Damien is a computational scientist at Oak Ridge, where he co-leads the Kokkos Performance Portability project. So Damien is maybe one of the best person to tell us about Kokkos best practices, how to integrate Kokkos in your project. And without further ado, Damien, the floor is yours.
Thank you. All right, so let's see the menu for today. So there's going to be two parts. In the first part, we are going to tackle integrating it into your build system, more build system generator, so with your CMake. And the second part, we'll look at the other thing you need to do before you can actually start using Kokkos, that is initializing the Kokkos execution environment. And we'll look at some considerations that are important when you integrate into a library or an application so that it can compose nicely with other library you might be using. Okay, so let's get started with the integration into the build system. Okay, so this is trying to give you a little bit historical context. In the times of Kokkos, the Kokkos 2X series, to give you a feel, we released 3.0 in 2020. So in around 2018 to 2019, we lived some difficult times in the Kokkos world where essentially we were mostly using the generated GNU Make files. You could in theory use CMake, but it was really, really brittle. And you could also build via Trilinos because, as you may know, Kokkos is being deployed as part of Trilinos as well. And that was very, very challenging because in the end, you had to write your own find Kokkos module. If you wanted to be, let's say, portable in the sense, be usable by people who have different needs, whether they need Trilinos or self-installed, essentially you had to support three totally different installation of Kokkos, and you had to do it everything by hand. For those who might have been at the first user group meeting we had in 2019, I actually gave an hour-and-a-half long talk trying to explain how bad that was, diffing trees and whatnot. So those were dark times. And so with 3.0 was really a major turn in what we were doing. Kudos to Jeremy in particular. I mean, there were other people who helped, like Daniel, and I think Nick as well. But the big thing in 3.0 was CMake was becoming the thing we recommend. The difficult thing was we were still supporting so these 3 bits, which you could see at some extension from CMake, which is used in Trilinos, and we are still supporting the generated GNU Make files. But we started changing our tone and saying CMake is the thing we want you to use. We still had a lot of small incremental improvement to do in the series, making it more or less irrelevant over time for you whether it was installed through Trilinos or through Kokkos. But this was at great cost. It was difficult. And now, we're about to release 4.6, so in the 4X series. Now we have a clear message. You should be using CMake, and we support different variants, which I'm going to cover in this first part. Essentially via the find package, which is basically finding Kokkos as an external dependency, or what I usually refer to as embedded Kokkos, basically building Kokkos as part of your code. So the 3-bit specific code path we had in Trilinos has been removed. You should not have noticed, but it was quite an effort, in big part done by Daniel. And we officially announced that we are deprecating the support for generating GNU make files, and we're going to drop it. Okay, so that was the kind of the historical perspective. So the thing I'm going to show you is what we expect you to be doing today. So if you're using any Kokkos that's from the 4X series, and in the foreseeable future, that's what you should be looking at. But if you're looking at this by some mistake, you're looking at this in a few years and you're way into the 5X series, I will, as usual, refer you to our documentation because things may change. We'll see. Anyway, so let's start with the most natural thing that we expect you to do in your project. And in the end, it's pretty damn simple if you're familiar with CMake. So basically, the Kokkos project define a Kokkos. So it's namespace. You see the Kokkos colon Kokkos, not the spelling with the uppercase K and lowercase k. It is what it is. But this target with CMake basically carries all the necessary information to be able to compile against Kokkos downstream. It will automatically carry all the necessary include directories. It's gonna link to all the right libraries, and it's gonna pass all the compile option that Kokkos is setting up for you. So you shouldn't be messing with any of these things. All you do is what you see on the right-hand side in your project. You will say that you want to find an external Kokkos install. So the syntax Kokkos, not the spelling is important, uppercase K. So you want to find an external install of Kokkos. The second argument, the 4.2, is optional, but it sets a minimum required version. You can even specify ranges. There's different syntax, but here, when you write that, you say, I would like to find a Kokkos which is at least 4.2. The required is important. It says that you want to fail at configuration time if you don't find it. And config is basically something that says that you do not want somehow to pick up someone that define how to find Kokkos. You want to only detect what was installed by Kokkos. And then the next line, the target link libraries. So you would have defined your own target, whether you're using a library, it could be your library or it could be your executable if you're writing in the application. And you will link against Kokkos. So you declare this dependency like this, like by doing my target, Kokkos. I won't spend too much time on the attribute private. This is about visibility and how that might be passed downstream. CMake has a lot of documentation about these things. Essentially, that would impact whether it's, if you were a library, whether it's transitively passed downstream. And so anyway, there's 2 lines is all our recommended usage is there's 2 lines is the only thing you should be adding in your project. And then when you are configuring your project, what you would usually do is you would tell CMake where to find Kokkos by passing this argument -d. The spelling, the case is important, so it's really case sensitive. So -Kokkos with a K uppercase, and root, which is a usual way you can specifically tell CMake where you would like to find Kokkos, and you give preferably an absolute path to where you have previously installed Kokkos. And voila, that's as simple what we recommend most users. But depending on your use case, that's you might actually want to bundle, if you will, Kokkos with your install. So basically have potentially Kokkos retrieved or snapshot into your source case already present, ready to be compiled just as part of your project. So that's just another valid approach to do. And here I'm going to present two different alternatives on how to go about embedding Kokkos into your project. On the left-hand side, this is one option where what you would do is you would use Git submodule to basically add to your project, assuming that you use Git, of course, but add the Kokkos source to your project. So here with this command git submodule add with the -b option, basically you're saying that you want to have in your project at the directory called, I assume you see my mouse, TPLS for third-party libraries, Kokkos. So you're going to download the version 4.5.01 there, and then you just commit it to your repo. And so now your project has everything in place to get the source. Usually we encourage you to do that again, instead of just copying yourself all the source of Kokkos and adding it somehow manually yourself. Because whenever you're going to need support or have problems, one of the first questions that developers are going to ask you is, what version of Kokkos are you using? And well, if you use submodules, that's going to be pretty clear, right? It's going to be embedded in your version control system, which version you are actually using. And so this thing is what you do to actually register the source code of Kokkos as part of your project. And then what you do is you use the add subdirectory and you give the path to wherever you install Kokkos. So here I said TPLS Kokkos, that's what I do. And then basically exactly the same command that I had on the first page, just as simple. I'm not reading the question, so if you need my attention, someone from the team, just let me know.
Do you prefer to take them now or at the end of the presentation?
If it's about what I'm saying and it's not something trivial that Thomas or anyone else can answer, just interrupt me.
It's okay. It's trivial enough, but this means that you need to have access to the internet.
Yeah, that's entirely. Yes, that's right. But presumably you're going to get Kokkos, right? So I would argue with you that if you're able to download Kokkos, then you have internet, and if you don't, well, whoever is getting it for you is gonna have this module. Someone at the internet at some point, and it's gonna give you what you need.
I also believe that you can point fetch content with an environment variable to pre-downloaded file.
All right, so you're going ahead of me. So now let's look on the right-hand side, the fetch content, which is another alternative where you do not put Kokkos directly in your source code. Basically, you use this CMake facility, which is called fetch content, where you basically tell CMake how to retrieve the version of Kokkos you would like to have. So sorry, it was hard to fit on the slide, but the idea is you're going to give a URL here. So I'm giving the path to the actual download archive for Kokkos. And then optionally, but recommended, you can actually specify the checksum, which is kind of a security feature that we publish these things when we do releases. Basically, it's a guarantee. You could see it as a way of checking the integrity of what you downloaded, making sure that there was no flip of any bit somehow when you download it, or more importantly, no one tampered with it, and you're not installing something that's not really what you thought you were installing. Then what you do is you call fetch content make available Kokkos, and the last line is the same thing as always. You just register your dependency with Kokkos. And yes, there are more advanced options. If you have similarly challenges with respect to network, there are options that you can use where essentially you can bypass the download step from the URL and just point somewhere in your repo to the place where you already downloaded the tarball. So there are alternatives that let you still be able to use this when you have a complicated network setting. But these are the two say recommended way of embedding Kokkos in a project if you have to. Remember, the first one is still what we recommend, but that's how, if you want to embed, we recommend one of these two methods. Here is the last thing that we can recommend, which is essentially taking a little bit of the two solution that I showed you before, external or embedded. And so it goes like this. Let's look on the right-hand side. So you attempt to find Kokkos. Here I omitted the version. It's up to you whether you want to specify a minimum or range. So that would go after Kokkos. And then you see I don't have the required anymore. It's not required. I am going to attempt to find it. And I still have the config because I really want to find whatever was installed with Kokkos. And so then after that, I use this variable that's being set by Kokkos by the by CMake by the find package call, which is it's always package name underscore found. So if Kokkos was found, it means that I succeeded to find an external Kokkos. So that's it. I can already jump to the end and link against it. But if I didn't, if you don't have it on your system or it failed, then you can fall back to something that retrieve a version that you want to bundle. So here, I think it usually makes slightly more sense to do it with a fetch content because it's kind of weirdish to have a bundled, a placeholder for Kokkos already in your code base, but still retrieve it. So I think fetch content is slightly better of a fit here. The block that I have as far as you're concerned, that this is just, I omitted the checksum, but this is essentially the same block you would have for fetch content. And then, yeah, the last line, as I said, is just linking against it. And even though you could try to reinvent all your own controls to decide, when you install your project, which method, if you could force one method or the other. On the left-hand side, I'm showing you that CMake, with more modern CMake, I think 3.22 or 23, have support for this variable called CMake disable find package. So if you do that, you're forcing, if you set CMake disable find package Kokkos to on or to true, you are forcing the fetch content. And conversely, you could set CMake required find package Kokkos to true, in which case the initial find package will fail if it doesn't work. So it's a way without coming up with your own convention, something like enable or force whatever, just use standard CMake support to control essentially externally how this find package or how this find package is going to behave. And here I just repeated the thing I had already shown you. You would use Kokkos root to help your project find the right Kokkos. So that's a more advanced pattern that we would usually recommend. With that, I am done with how to integrate it in your build system. So I suggest I take any CMake related question now. And then I'll go into initialization. If you want to ask me a question, just unmute yourself.
I guess in the chat we had a few more fetch content questions than Kokkos related. But are there any other questions?
Okay, then I assume these things are being answered if it's trivial fetch content. I mean, it's things that you can find documentation for on the CMake website. But there's external Kokkos or embedded with two ways of doing it, or a mix of the two is what we recommend. You would find these things, we have it in our get started section on integrating Kokkos, but yeah, that's what we recommend. Okay, so now let's move. So now that you got Kokkos hooked up to your build system, now let's try. You want to start using it, but there is still one thing you need to do. You need to initialize the Kokkos execution environment before you can actually use anything. So let's see a bit what we recommend. So to use Kokkos then in your actual C++ code, you need to do two things. You need to include Kokkos, so the generic headers that we tell you to use in all our tutorial is this Kokkos_core.hpp, which bring all the main things from Kokkos core. So you need to put that in your source code. And then, so when you write your main, you're going to need to initialize Kokkos. And the most recommended thing that the best thing you can be doing if you're writing your main is to pass through argc and argv. Argc is a counter for the command line arguments that are being passed when you call your executable, and argv are all the command line arguments that you might be passing. And when you do so, it will let you or whoever is running your code later pass Kokkos specific command line argument that Kokkos can recognize that can control a bit what Kokkos does. So for instance, you could ask for help if you don't remember what the options are, or you could set the number of threads, or you could select a peculiar device. So it's pretty simple, right? You initialize Kokkos before you use anything, and you pass through argc and argv. And this code is pretty irrelevant. I mean, I construct a view and launch a few things. And you can find it. I just took the example from our get started. But the important thing is you see this pair of braces. An important thing is before you call Kokkos finalize, you need to make sure that all the Kokkos objects that you have are cleaned up. So the view here, this curly brace, when it closes, the view gets out of scope and it gets deleted, which means then the memory is being freed, and then you're safe. You have to call finalize. And voila, we release all the resources that we acquired in initialize. If you are familiar with MPI, nothing from what I say should be too surprising, right? With MPI, you have to include the MPI header, and you do MPI init or MPI init thread if you're more modern. And then when you're done, you finalize. The semantics are the same. You can only initialize Kokkos once in your program. And you must finalize at the end. And you can't reinitialize. It's really only once, and if you do, you have to finalize. Okay, so this is, if you write main, this is what this is now most recommended way for most purposes. But so now a little comment about what if you're using Kokkos with MPI. So if you do use Kokkos with MPI, the recommendation is you initialize MPI first. So MPI is a C interface. They like taking things by a pointer to the actual information, hence the ampersand. So you initialize MPI and then you initialize Kokkos. And when you're done, so you would have your program, then you finalize Kokkos and then MPI. The gist of it is that if you do initialize MPI first, then Kokkos can detect that and can do the right thing for you. That is, if you're running on a fat node that has multiple GPU, you probably don't want all your process to use the same GPU. You probably want to, select, have the different runs, select different GPUs. And if you follow the recommendation highlighted in red, this is going to be done automatically for you. You don't need to do anything. If for some reason you want to choose a different mapping, you can either, so it would be a weird usage, but why not? You can change the mapping strategy by saying random. I mean, why not? It's your choice, right? Your program, if you really wanted to do that. It's missing an equal, by the way. And you could also, sorry, force the GPU selection either via a command line argument or via an environment variable. But essentially for virtually all the normal usage, this is going as long as you remember to initialize MPI first, this will do the right thing. Okay. So now I am gonna look at
yeah. Damien,
yes.
there are two questions in the chat. One is why use initialize finalize rather than a constructor and destructor?
You're talking about scope guard?
I guess that's the answer to the question, yeah.
Well, you know, I could have tried to fit everything on one slide and have a map and spend 20 minutes on it, or we'll get to it in 2 slides or 3 slides. And
okay, so it will come. And the other question is, I assume that Kokkos honors whatever Slam did to map GPUs to processes.
say again, sorry.
I assume that Kokkos honors whatever Slam did to map GPUs to processes.
That's the intent. And if you are on system where it's not done properly, then you open a bug report. But the intent is Kokkos should interact just as you would expect with any of the schedulers and maps the way you would really want this, like take all grabbing successive GPUs. Anyway. Let's march because I still have a few slides. So here it's okay. What happened if for some reason, so the main is irrelevant here, but if for some reason you need to do something, you need to mess with the initialization setting. I hope you have a good reason if you really want to do that. But if you do, you don't have to mess with a C array of a pointer towards strings. We have a class which is called initialization settings, and you can define an object if you want and set the thing in multiple call, or you can do it in one shot here. So for instance, you can say set disable warning true. So it means I don't want to see any warning. We do not recommend that, but you could. You could change the mapping and you could say, I only want to use one thread. If for some reason, in your use case, you really, really don't want to let people change it and you really only want one thread, you can do it programmatically. The idea is that any of the Kokkos option has a set function, which is the one you're usually going to use. If somehow you need to query what was already set in the setting, you can use the has. And if you need to read the value, you can use a get. Just like with stud optional, if you read it, you better be sure, if you do get, you better be sure that it has been set. Otherwise, you get undefined behavior, just like with stud optional. And so here to illustrate, you could, if somehow someone is handing you a setting and you want to see if it has a device ID set, you would say if it wasn't set, let's use the device ID one. You could do that if you really wanted to. And so here, after this logic, you know for sure that it's going to have a device ID because you just set it if it didn't have one. And then, so if you wanted to do so, you could print it. So that's the logic. I will refer you to the documentation if you want to see the list of options, or even better, you just do help. And it's going to tell you what this option might be. Okay. So I assume that's what the question was about. There is an alternative to just explicitly calling Kokkos initial finalize, which is we have something we call scope guard. And you pass it argc argv. It basically it just forward the arguments to initialize. So if you want to use scope guard with initialization setting, you can. And so the idea here is, so I wrote inside the main, but it's just anywhere, right? The idea is here, there is no surrounding curly braces. So what happened here? is when your program returns, then the view here, the view destructor is being called, so which frees the memory, and the scope guard has been created before. So only after the scope guard the destructor is being called, and this thing is calling Kokkos finalize underneath the hood, and it does the rights to clean up. There isn't, it's honestly, it's a matter of taste. If you're doing some small things, some small hello world thing, and you like scope guard, use scope guard. But there's nothing wrong with Kokkos initialize and finalize. Typically you would write initialize and finalize in your main, and then you would probably not write your entire program in main. You would probably call function, so it would automatically add the scope. So it's really in the end, it's really a preference which one you pick. One exception is if you did have some logic in your main with a control for and potentially things that throw. That guarantees that if there is early return or anything like that, that the cleanup is going to be done. But honestly, it's quite marginal use. Most of the time, it just lets you, it doesn't force you to add an extra scope, but it's mostly for toy problem. I don't think it's really critical in real applications. Anyway, this thing exists, and if you want to use it, use it. Okay. So now these are the last two. So I want to be really, really clear that until now, there were pretty common things that we recommend. And yeah, by all means, use scope guards. If you have to use initialization setting, most of the time, the truth is you don't need to, you just pass argc-argv. So now is an advanced case, and I want to cover it because we want you to do the right thing if you really, really have to. But this is really, especially the left column is a last resort type of thing. So the thing is, what happens if you do not control writing the main in your program? So let's say you're writing a library, right? You're writing a library, you're using Kokkos, but you don't actually get to write the application. And so what we recommend, number one thing is, well, better things is to say, if you can, if you always use Kokkos, is to give it up. Just tell your user that you use Kokkos and that a precondition to use your library is that Kokkos must be initialized before you use, you use the library, and must be you must clean up everything before you can finalize. This is a very good, viable strategy. That's what most of our flagship library do. Like that's what Cabana does. That's what Arborx does. That's what Kokkos FFT. That's what Kokkos kernel do. They clearly depend on Kokkos, and they, it's part of the specification. Kokkos needs to be initialized before you use them. This is what we recommend. So now, what if you have some users that are going to use your program, but that actually it's optional, or they don't actually, you somehow cannot do anything else. Like you cannot force on them to initialize Kokkos. So if you really have this problem, and again, like really think hard if you're obliged to do that, then you will have to somehow initialize Kokkos before you start using it. And here is a pattern that's proven and that works. So what you're going to do is before you call your APIs or you construct anything from Kokkos, you're going to detect if Kokkos was initialized. And if it has not been yet initialized, because ideally, again, it's a precondition and someone else has done it for you and you don't need to worry about it. So if it hasn't been, so here, so let's look at this. So this pattern, there is a static variable in this function. And then it's called an immediately invoked immediately invoked lambda. So it's a syntax. If you're not familiar with it, you can just look it up. But essentially, what it guarantees, it's thread safe. It's going to be called only once. That's why you can call it whatever you want, the variable. And so what happened is the first thread that gets in is going to check. Is going to ensure that Kokkos better not have been finalized, because if Kokkos has been finalized, you're screwed. Right? You absolutely cannot reinitialize Kokkos. You cannot use Kokkos. So either you have something sensible you can do, or all you can do is tell them, like notify them there is an error. Otherwise, you will check if Kokkos is not currently initialized, then you initialize it yourself. Here I chose to initialize with no arguments. You could programmatically pass some argument. This is in general problematic, this pattern, because if you really cared for some argument to be set, well, it might have been initialized by someone else, right? So how do you know that these things are actually consistent with what you're setting? So, it's really a last resort thing. So you check if Kokkos wasn't initialized. You absolutely need it to be initialized now, so you initialize it. And then, so this stood at exit thing is something from the standard library, which basically tells to the C++ runtime that when your program exits, last thing to remember to finalize Kokkos. So basically, it's registering a call to Kokkos finalize to be called at the program cleanup. And then, so this thing is only going to enter, so the static variable is only going to be initialized by one thread once. And then, basically, every time there is a next call, subsequent call, you're just checking that Kokkos is still initialized, essentially that it's not, that it hasn't been finalized and it's still okay to use it. And voila. So again, last resort. Better not to be in a situation like this, but if you are, this is a good way of doing it. Okay. So now on the right-hand side is another advanced case where it's a bit slightly better. I mean, you can combine them, but the idea is here we put aside the problem of whether Kokkos is initialized or not. We say Kokkos is initialized. This is a precondition. So whether you did it yourself or whether it's a precondition of your library, Kokkos is initialized. But now, let's say you need to manage some sort of resources with your program. Maybe maybe you want to cache an allocation or something like that. And for performance reason, you don't want at each API call to deallocate and reallocate. That's inefficient. So what you could do is you have a similar pattern where you are going to check that Kokkos is initialized. And on the first call, so you again have this trick with an immediately invoked lambda and a static variable. And so what you do is the first call, you're going to check, you're going to ensure Kokkos better be initialized now. And so what you're going to do is you're going to acquire your resources. So that's here that you would maybe, initialize some static views that you're going to reuse in your API calls or whatever is relevant for your problem. And then, so what you do is you use push finalize hook, which is the Kokkos counterpart to stood at exit. So what it does is it registers a lambda to be called when Kokkos is finalized. And this basically tell you don't it's not you initializing Kokkos. So it's because you didn't initialize Kokkos, it's not your responsibility to finalize. But what you do is you tell whenever Kokkos is being finalized, please clean up my stuff, because they need to be released, there's resources by the time Kokkos is finalized. And voila. And then so in the path for subsequent call, you just check that Kokkos, ensure is initialized. You basically ensure that Kokkos has not been finalized. So that's this pattern, for instance, you can find in Kokkos FFT. So I apologize if I went a bit fast, but don't worry too much if it was over your head. This last example, these are advanced case. They are rare. But so the left one is really a last resort one, and the right one is basically a better alternative than rolling your own initialize and finalize. And with this, I am going to take questions.
Thank you very much, Damien. Maybe before we switch to questions, let me share a little bit of information. If I can share my screen, yeah. As usual, if you want to know more about our tea time, please come check the info at the cexaproject.org. Now it's also available, thanks to you, Damien, on the Kokkos website. Our next tea time will be about something that is not really Kokkos based, but that is related to GPU at large, Solomon, unified schemes for directive-based GPU offloading. This will be presented by Yohei Miki from the University of Tokyo. And as we said at the beginning of the presentation, be reminded that in May, from the 5th to the 8th of May in Chicago, is the HPSF conference. Please register as soon as possible to get the early bird level of price. The conference will be 4 days, 2 days about HPSF itself, but it will also host during 2 days the Kokkos user group. So if you want to meet the developers, to meet the community around Kokkos, this is a great place to go. And with that being said, I believe we had a first question in the chat.
Yeah, I'm looking. So Kevin, yes, we honor whatever Slurm does. And another thing is, I don't want to get into too much detail, but it also honors visibility setting of the GPU. You can, just like with CUDA, you can kind of set a visibility and hide some GPU, kind of mask them, and Kokkos is going to honor this. Then Martin's question. So if you initialization setting, it's kind of like a collection of optional. So when you initialize it, there's nothing in it. There's absolutely nothing in it. It's an alternative to argc argv. So regardless of whether you use argc argv or initialization setting, when we initialize Kokkos internally, we're going to look at the environment variable first, and we're going to parse them. And we do what you would expect, what we usually do in the Linux world, at least, or in most applications I know, which is command line arguments, or here, because it's equivalent, initialization setting, they take precedence over environment variable. So environment variable we always look at them, but if you set something as explicitly in initialize, it's going to take precedence. Meaning, if you said Kokkos device ID 2 as an environment variable, and someone pass a command argument that says something else, we are going to honor the argument pass to the initialize.
Maybe an extension to the question. If you want to take the command line argument, but only force one specific argument, is there a way, for example, to construct the initialization settings from argc-argv? No. Okay.
No. And we, unless you come up with very convincing use case, we've already said no to that in the past. Honestly, like in 99% of the case, you use argc-argv and don't bother with the other one. Only if you really have a good reason for preemptively removing that level of control to your user, and you know what sensible thing to do, then use it. But otherwise, just use argc-argv.
Just before you answer the next questions in the chat, let me just say, if some of you want to raise hand and ask the questions using your mic, it's also completely fine.
Yeah. Okay. Okay. The answer to C, Corinne, essentially the GNU generated GNU make files, we are pretty clear now that we're gonna remove it within, so they're deprecated, and 5.0 is coming at the end of the summer, and you know, we are allowed to just remove it then. So you should probably be thinking about transition paths. Then can Kokkos be configured with HW lock? Yes, you can, and yes, if you have it installed, yeah, configure with it. In general, yeah, if you have it, you should do it. It's a good habit. We don't do the smartest thing at the moment with it, but if present, we can configure at runtime configure Kokkos in a better way. Yeah, Ramsey, just unmute yourself and ask your question.
Yeah, can you hear me?
Yeah.
Yeah. So I have a question. So we started using Kokkos. We are really happy with it, and then the next move was to include it in a big project that strongly relied on the eigen linear algebra library. And what we found out is that eigen was causing a couple of issues, bugs, and compilation error that were linked more to the use of NVCC compiler. And the question is that, is there any hint or strategy when you strongly rely on a library and that was designed to run on GPU, and we found out that it was not
So does the eigen that you work
so
with enable CUDA?
Yes, I mean in theory, but what we found out is that it was not covering everything, and even for code that should run on the host, it is not working actually.
So you're immediately falling into a pretty advanced use case that I can probably not just answer in a minute here. So I encourage you to meet us on the build channel on Slack and ask your question. There are some, you fall already in much more advanced cases, and there are some consideration, but I would have to ask you a number of questions about your build system before I can give you good advice.
Okay, thank you.
Okay, so that's a good question for Slack. Christophe had a question. You can open your mic, Christophe.
Actually, there is some German colleagues did an interface between Kokkos and eigen. And they have some nice benchmarking with and without eigen and Kokkos, of course. So they have a framework called Kokkos that allows, it's on GitHub, that allows to properly use Kokkos with eigen. So everything is available. So we are looking for the same kind of environment actually, because it's nice to be able to use eigen. I was wondering, so regarding the question, I was the one who asked the question regarding HW lock, and what I saw was that so the number of threads, the setting of threads was quite interesting, but also there is a part with NUMA, and I saw that there are several things regarding NUMA, but the interface is rather poor in this area.
So when you talk about the interface, are you referring to the Kokkos HW lock thing, or are you
Yes.
referring? Yeah,
Yes.
this is okay.
And
So
just
the HW lock
follow up,
support in Kokkos has aged, and anything that's called Kokkos HW lock, you will probably notice there is no documentation at the moment. It's considered private. So talk to me. You should not be using it directly.
Okay, because the thing is that we realize, so writing codes with Kokkos work perfectly fine, but then when we actually plugged into our entire framework, for example, in the stack, we have something like Petsy, which also uses Kokkos, but Petsy was not compiled with Kokkos support, right? And then what we add is that when compile something very weird, so I don't like saying something like this, but just to state what happens is that the performance dropped tremendously just in multi-thread environment. At the PET-C level, PET-C dropped in terms of performance by a factor, I don't know, 10 or something, just by linking with Kokkos. So somehow there is some weird side effect that so far I couldn't find where is the problem. So I look forward showing what's going on and talking to you on Slack.
Essentially, if whatever library you're using, whether it's PET-C or other math library, if we don't make them kind of agree on how to use multi-threading, and if you mix use, you can degrade dramatically performance. Yeah, that's.
Yeah, I thought that it was probably something like this or some kind of conflicting use of the multi-thread part. Yeah.
Yeah, let's take this thing offline. Comment on general, and let's see how we can help you with this. You have the same problem, Felipe. So, what problem do you have, Felipe? Do you want to unmute yourself? Usually, if you use OMP num threads or all the settings, Kokkos is not going to mess with them and is going to honor whatever your choices are. Felipe? Oh, okay. All right.
I did unmute, but there seems to be an issue. So I propose to take any further questions on the Kokkos Slack, or even better, come and ask them directly at HPSF conference. For the Kokkos Tea-time, we will see each other next time on April the 16th. So see you in 1 month from now. Bye-bye, and thank you again, Damien.
Plaisir. Bye.
Thank you.
Bye, thank you.